Okay, guys. Right? Guys, do you realize this weekend, did we talk about this? You get an hour back, you get an extra hour, and you don't have school Monday and Tuesday? Yeah.
Oh, I thought we lost an hour.
No, this is the fall back. You get an hour.
Like an hour?
An hour's an hour, though. Saturday into Sunday. It's like 2:30 in the morning.
Like a Wednesday, oh, you get extra hours.
And then, guys, did you realize after this week we only have 10 days of school and then it's Thanksgiving break?
Oh my God. Are you serious?
How long is Thanksgiving?
I know, I'm just saying you're good news.
How long is it?
It starts on the 21st. So I updated the calendar. So next week, guys, you're gonna have school Monday, Tuesday, and then look, it's only black. You're literally making my day. Right, no school at all that Wednesday. I know. Great day, right, guys? All right. I can't really turn this without kind of making a mess, so I'm just gonna redraw this over here. We have a little circle, and then we have like.
It's just a logo.
All right, we okay? When are you making a new friend?
I love you guys now, but I still want to be with friends.
No, we're not leaving the whole front row empty. That's so weird. That never happens. Do not like that. You just missed one. Okay, guys, let's look at our circle here. We know this point. What this is in your package. 3.5? Yeah? Like this is this yeah, that's your okay. Cruise through everything. Yes. All right, we know that stuff, right? Hopefully we know that stuff.
What is that?
Okay, then I'm going to label a couple of radians, well, more than a couple. This is pi over 2, pi, 3 pi over 2, and all the way around would be 2 pi, right? So far, this is nothing new, right? Okay. I'm going to label things on this grid now. On the x-axis, I'm going to put my radians. So I'm going to just do these basic ones from our circle. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, I'm just working my way around the circle. And we're going to graph sine of x first. That's the equation I'm going to graph. So let's look at our unit circle. My sine values, what do they, like, what's the range of them? What do they go from? What's the smallest and the biggest? -1 to 1. Okay, so over here I'm going to put a -1. I'm going to put a 1. If you guys like color coding for graphing, you may want to get out your colors today. Probably like red and blue, maybe some purple. Alex, blue pair of pants. Are you okay?
How many colors are you using?
3. Oh, okay, you're ready. Those are the best pens. Aren't they? Oh, great. I like those too. Maybe I write the accent. Yeah, those are good too. I like your variety of colors. All right, guys, so let's look at this. If I am at 0 radians or 0 degrees, Ignore the graph over here right now. Just look at your circle. I'm right at this point. What is the sign of that?
0,
0. That means on my graph, I'm going to have a dot at 0, 0. Okay? So the input that I'm putting in is the radian, and the output is the sine value I get. Okay? So if I go to pi over 2, what is the sine of pi over 2? So that means at pi over 2, I have a point now. When I go to pi, sine. Okay. What about at 3 pi over 2? Up and down and curvy, yes. And at 2 pi. I know. You didn't even know. That's going to be 0, right? Okay. Do you guys recognize that I could keep graphing this forever? Like, you know, we can go around the circle over and over. Your graph is going to continue forever. Okay. Little dance back there. I like it. It's a sinusoidal graph or sinusoidal. I know it sounds like I'm just making up words today. It just means it's got that wave pattern. Okay, it's a sine curve. Okay, so think about how we're going to connect these. I could certainly plot some more points along here, but they're kind of ugly to plot. So let's think about the shape. This is a curve along my circle, right? So what do you think the shape is going to be here? Curve, yeah, not a straight line. These graphs are not like sharp and angular. Okay? Those are all in one curve. We haven't done any transformations yet, so. It's okay. If you made it, you know, fun and festive, that's all right. When we get to the transformations, that's when I'll be using lots of different forms, okay?
That already doesn't look like
So I will walk you through it. We were bringing any questions on that? That is your parent graph for sine of x, okay? Everything else we do with graphing sine will come from that graph. We're graphing, yes. Good pickup. Yeah, we got it. All right, what we're going to do next is cosine. So I want you to do the same thing. I want you to try it on your own. Give me a minute here. We are not doing inverses yet. That is far away. We will do them, but... When I'm at higher oh, they're always out. Yep. Yep. You can think about concavity when you're drawing it, like it's concave down and then switches to concave up. Alright. The X value okay. So things like
Oh, that's so good.
like this. Sounds good. Yeah. That's perfect. All right, guys, I think a lot of you are good with getting these points, right? Are you a little scared of drawing it?
Yeah.
It's really, it is not an absolute value graph. Oh, no, so wrong. Okay, think about sections. Concave down, concave up, concave down, okay?
Accelerating.
It's a wave, guys. Okay.
Accelerating stuff.
All right, questions on the two period graphs. You must know these. They come from the circle. So again, it's back to knowing the circle, right? You don't like the circle? Well, I'm not going to quiz you on trying it again. You got the method. So we get into polars, you have to understand. We get into trig groups. We'll go away for a while. And those trig quizzes, the time trig quizzes, those happen all year. All right, guys, let's turn the page. Retakes? Yeah. I can share your score. If you want to come in and see it, you can score Warhawk time. All right, everybody here? Okay. So this just got a lot more complicated looking than the parent equation, right? Okay, but a lot of it you know. Let's think about when you graph. If you have a coefficient in front, what does that tell you? Vertical stretch or compression, okay. So changing A, that's a vertical stretch or compression. And what if A happens to be negative? Over, good. I should say if negative. Over x-axis. All right, we're going to come back to B because that's kind of the weird one. What do you think C is doing?
Right or left?
Okay. Horizontal shift. Sometimes it's called a phased shift. And that just means like right or left, okay? That's nothing new from graphs you've done before. laser tag?
Please shift that would be awesome.
All right, what do you think about D?
No, yeah, right.
Yep, vertical shift, vertical translation, sometimes we use that. Basically, it's the up or down.
You will get there.
Okay, then what's B gonna do? Yes. It's going to change the period of the graph.
What do you mean by change the period?
So let's look at like this parent graph. And you can even think back to the circle. What is going to happen to this graph after 2 pi? It repeats, right? It starts over. So it takes this distance of 2 pi to get the entire graph to happen, right? Which makes sense because that's once around the circle to see all the values, okay? If we change that b value, it's a different length for that to happen, okay? Which makes sense, right? If I compress the graph, I'm going to see all of it by the time I get to pi. Or if I stretch it out, it might take me till 4 pi to see all of
So
it.
it's like equals.
Yes. Mm-hmm.
And is it the same where like a fraction actually means it's gonna be longer and
Yep. Like if your b value is a half, you're going to see half of this graph by the time you get to 2 pi. Okay. If your b is a 2, you're going to see 2 of them by the time you get to 2 pi. Okay. All right. So, a lot of that. Yeah, I'm not really going to do that to you because with graphs like this, all right, so these are kind of some of the terms that we're going to talk about with our graphs. Amplitude, it is that distance from the midline to the top of your graph. It's like half of the range or half of the height of your graph, okay? From your equation, the amplitude is always equal to the absolute value of A. What do you think the midline is? On the parent graph, it's 0, but it's not always going to be 0, so how else would you describe it? It's D. Good. Whoever said that, yeah, good job. It is D. Your midline is always going to be equal to your vertical shift. Okay, it's right in the middle of your graph. It's halfway between the top and the bottom. You shift up or down, it moves. Okay. All right, so the period or the wavelength, how long it takes for the graph to start repeating, we have a formula for that. It's always equal to 2 pi over b. Which is why if it's a half, it's actually bigger. Yeah. Okay. Yes. So far? All right, when you're ready, go ahead and turn the page. Do you look back there, or you just leave yours up? Okay. Now we get to graph some. Woo! All right. Okay, so the first one, cosine graph. What's different about it? There's a 4, yes, so there's a b value. All right, I'm going to use, on the y-axis, I'm going to use each tick mark as a half because it's kind of small. So I'm going to make 1 and -1. Take care of that. All right, the normal labels that we had with our parent graph were pi over 2, pi, 3 pi over 2, and 2 pi. We're going to change those because we have a b value this time. Okay, the b is 4, so let's think about what that makes the period. Because we know the period is equal to 2 pi over b. And in this case, our b is 4. So 2 pi over 4 is going to equal the period. So what is the period? Pi over 2. So what do you think? The period is how long it takes for the graph to like start over.
Oh.
Okay? So if we didn't relabel anything, that means, don't write this part down, that means I would see my entire cosine graph by the time I got to pi over 2. Okay? I don't want you to graph a million of these. So what we're going to do is relabel our x-axis so that we can see everything that's happening. So the last tick mark, instead of being 2 pi, what do you think I'm going to change it to? Oh, good. And I got that by dividing that label by 4, right? Dividing by my b value. So what do you think 3 pi over 2 is going to become? What do you think? Oh, okay. Not 6 pi. Guys, this is pi over 2. It's probably going to be smaller than pi over 2.
I own 6 pi.
What? Not quite.
Pi over 6. No, just kidding.
I like the enthusiasm.
Pi over 3.
All right, guys, let's do some fractions. It was 3 pi over 2, right? I am dividing by 4.
Oh, 3 pi over 8. Oh, okay. 3 pi over 8.
What?
3
Oh,
pi over 8.
it's like that, right?
3 pi over 8.
Okay. We can do this.
Look at that. Oh, so
All right, what is pi going to become? Pi over 4? Right. What do you think pi over 2 is going to be? Where's that guy? All right.
Oh, I got you. I got you.
the pi rate.
Oh, you're just right.
I'm taking those original labels from the circle and just dividing them by 4. Also, guys, you have very good number sense. You can probably just see what's happening with the fractions. Like, yes, no, yes, we like fractions, we don't like fractions. Always look at these and make sure they're actually in order. Like pi over 8 is smaller than pi over 4, right? Yeah, okay. Does this make sense what we've done? Okay. So now I can plot the points exactly as I had them for my parent graph. Okay? So don't, it's very weird to say, do not think about the values. Think about the pattern of the parent graph. So I'm going to have, cosine was the one that started up at 1, right? And then it was 0, and then it was negative 1, it was 0, and then it was positive 1. So I am seeing the entire graph by the time I get to pi over 2. Okay? It's like we just zoomed in on that first little section so that we can see the entire graph. Does it make sense how we're doing this?
Yeah.
Okay. Labeling your x-axis is crucial. Otherwise, they're going to look very, very similar to the original. Okay? But it's not, because the period has changed.
Wait, so which one is 10? If I actually see that, we need to change the numbers at the bottom, or we actually
No, don't do that. Yeah.
Oh, okay.
Yeah. It's much easier than trying to like squeeze it in. Yeah. In the directions, I actually said graph at least 2 periods of this. So, could I graph it to the left? Yeah, what would my labels be over there? Yeah, negatives of them, and then what's the pattern going to do? Yeah, and just like talk yourself through it. High, middle, low, high, middle, low, middle, high. Like, it's just gonna follow that wave, okay?
Even on this test, we can talk about it.
Yes. Quietly. All right, we okay with that one? Okay. That's the answer for one. You're done. Okay. Got it? Okay, so let's look at 2. What's happening on 2? Yeah, we've got that -2 in front and a b value, right? Okay, let's label first. What is b? 1/2. What does that make the period of this graph? 4 pi. Yes? 4 pi, yes. Getting close to Thanksgiving, pi, you know, all good. That's 4 pi. Do you know the other labels?
Pi and 2
Yes.
pi.
Perfect. Question? I'm going to label them over here too, my negatives. Okay, I am going to put dots of the parent graph. I'm going to do them in green. It's signed, so I know that starts at 0, 1, 0, -0. I'm not going to connect these. I'm just putting them there kind of as reference. Then my final answer I'll put in blue. So what do I need to do with each of those dots? And? Okay, so can I just multiply by -2? All right, and what am I multiplying by -2? The y values. So the ones that are at 0, are any of those going to change? No. So I can put those in. This one that's at 1, what is it going to become? -2. And this one that's at -1 will become? +2. Okay. Do you see why I like colors? Look, if that was all in pencil, I would be like, I do not know what dot is what. Is that how you feel right now? Yeah. Okay. All right with that one? Make sure. Wait a minute. Make sure everybody's okay. We gotta baby step our way through. Don't leave anyone behind. Questions so far? Okay. Let's look at 3. Oh, Johnny.
Is the inverse, the negative part of the fraction going to be the same as the positive part? On this, they're mirrored.
It's gonna follow the pattern though. Every text today.
So whenever it's flip it.
Yeah, I think that was really wrong.
Okay. This one you start.
Just All right, let's look at 3. Is there anything to mess with the labels on my graph? No. So I'm just going to go with the pi over 2. Pi. Write them down. It's okay.
Yeah.
I'm not going to mess you up and make you white out things again. All right, so again, I'm going to do it in green. I'm just going to plot parent graph dots, okay? It's sine. That's the one that starts in the middle, 0, 0. All right, now what is happening in this one? No, that's not what's... Which way? Right, to the right. How much? Okay, pi over 2, which is 1 tick mark, okay? If I ask you what the shift is, tell me pi over 2, don't tell me 1. Okay, but yes, you were thinking 1 tick mark. So since I'm going to the right, which side of my graph should I start on? Flat. Yeah, I'm going to start over here. So this dot is going to get moved right here. This dot here. This dot here. Just start shifting all of them until you get to the last one. The dot that's at 2 pi doesn't really have anywhere to go, right? Okay? Yeah. It depends on what I ask you. If I ask you for one period of the graph, no, just do one of them. If I say 2 periods, then yes. Yep, so just read the directions. Blue is the final. This is the shifted. See why color is helpful? Okay. This will just be dots everywhere. So let's look at the pattern. I'm okay over to here, right? Like I can end here. I need to figure out what's happening here. You guys know what it's going to be? Low, right? Okay. And you'll notice where you end and where you begin, they're always the same, as long as it's a full period of the graph. So. Number 4, I'm going to change it slightly. I don't want it to be pi over 4. I want it to just be pi. So x plus pi. I want you guys to try to graph this one. Hold on. Sorry. Number 4. I changed it to pi instead of pi over 4. Okay.
Nothing's inside. Nothing's in. It comes around.
How did I put it in? Maybe not.
There you go. I'm gonna escape my grass. You just
Okay, if you don't see a grade, like if any of your test grades change, that means you didn't do better. I didn't put it in. Okay. But if you want to know what you got, just let me know. Anybody want to know?
okay.
Yeah, that was okay.
I don't understand. I recovered my grade.
It's why we don't put it up there anymore. I need to go back through and just double check homework. I honestly don't know. Like, I can't see it either. I mean, I can change things so I can see it. I want to see it. Because it's already, if it's an 89.5, it'll give you an 86. So it means you're not at an 89.5.
That's what I said.
I don't know. I can do it. It's just like, it's like 90%. Yeah, it's simple.
On my words.
All right, guys, let's look at this one. Which way are we going here? Okay, left by 5, which is 2 tick marks, okay? And then down 1. So I'm going to start on the right side since I'm going left. All right, guys, and do you know where your dots go on that right side? Yeah, right? A middle and a low?
So I think earlier I was rounding up to the 89. Now I'm in the
Okay. All right, how do we do on that one? Oh, my page back here.
No, I just, like, even if you went, like, the other way, like,
So if you put the sign, you're okay. Sign, you will be wrong. All right, guys, let's look at number 5. This one looks kind of ugly, right? Okay. When you have a B value that's going to change the period of the graph and you have a phase shift, meaning the left or the right shift, You must factor first. What must you do? Okay, good job. So this is really y equals 3/2. That is not a 2. That's a 5. All right, 3/2 sine of 1/2 x minus 5. Okay. And then plus 1 is out here. Does that make sense? Always double check, like once I factor it out, okay, if I multiplied 1/2 x and 1/2 times pi, yep, that would be pi over 2. I factored correctly. All right, now I want you guys to try this out. You got to relabel. You've got a vertical stretch. You've got a phase shift. You've got a vertical shift. A little bit of everything. And practice. They're going to be guys, think order of operations. You would multiply before you'd add or subtract, right? So relabel your x-axis and do that vertical stretch before you do any sort of shifting. That's like 5/3. Yeah. Going by on your y-axis. No, because that's I mean, it's fine. That's why you have to label it. Then you're going all the way up to like. For the top, yeah. I got 1 point. Right, right.
Oh, and I gotta move it up. Yeah.
Just one.
Oh, you know, so,
It's been a long Thursday.
It's been a long week, guys.
Like this Thursday.
Okay. I have a student in second period. Mine is so ran into a brick wall. So I was like, she's like, I hit a brick wall today. And I was like, oh, thinking like mentally, like I hit the wall. No, she literally hit a wall. Okay, things are gonna go up from there. Okay. Yeah. So feel like you're having a bad day. You didn't run into a wall. You're okay. Oh no! Do you want another minute, or do you want to look up here? Oh, okay. Sorry. No, I just want to know. Okay. -2, -1. I don't know. Oh, okay.
Do you do the shift first or the stretch?
What do you think? Do you multiply or
Is that what you
subtract?
got?
You both do stretch
Oh,
first?
well, what do you do first?
So you do the stretch first?
Yeah.
How do you stretch something when you catch up?
What is it times 0? Yeah.
Why would you do that? So it's a vertical stretch, right?
Yeah. So the ones that are on the x-axis, even after you stretch, are still on the x-axis. Because they're still right in the middle,
I
right?
saw the pan function every time.
I would think about those dots every time. Don't draw the actual curve. All right, guys, let's look. Okay, guys, instead of just plotting the parent dots, I'm going to go ahead and do the amplitude change, the vertical stretch, while I do that. So the points that are at 0, are they going to go anywhere? No, not in the initial step. They are not. And the ones that are at 1, where are they going to actually go? 1 and a half. Yeah. You meant get taller by a half?
Yes.
All right. So I'm going to go there. This is going to be up here, 1.50, negative 1.50, right?
That's the scariest thing I've ever seen. It's not even like a scary
Okay, from there, where do I go? Where am I shifting?
Right to the right. Uh-oh.
Okay, right 5, which is 1 tick mark, and up. Okay. All right, so I've got to go right by pi and up 1. Right by pi, up 1. So the top of my graph's all the way up to 2.5 now? Yes, okay. Your midline is at 1?
Yes.
Yes, okay. And your minimum is at negative 0.5?
Should we draw them?
You don't have to. You can if you want to, if it helps you, absolutely. And then I know the ending and the beginning. That's it.
Oh no, I did it right.
Okay. Definitely read directions.
Yeah.
Yeah. You go left instead of right. That will definitely change it when it's time. All right, guys. Any questions on the graph? Okay, now we're going to go in the other way. You're going to be given the graph or information about the graph. You have to write the equation.
Do it. I'll do it in less than a minute.
Sounds like quite the challenge. All right, let's look at 6 together. Okay, so the graph has a period of 3 pi, an amplitude of 4, a phase shift of pi over 3. What that means is that we're going to the right by pi over 3. And a midline of y equals -2. We're going to write an equation. I did not tell you whether you're writing a sine or a cosine, so you could write either one. I'm going to write a sine equation. All right, amplitude, that's the easy part. One of the easy parts. What am I going to put in front of my equation? 4. 4 sine of something. The period is 3 pi, which means b is different. Let's think about it. 2 pi over b has to equal the period, right? So that has to equal 3 pi. What do you think b equals? Not
2 over 3 pi.
Let's just
2/3 pi, yeah.
2/3 pi?
It's true.
It is 2 over 3.
I forgot.
Okay? That b value is what you plug into your equation. Okay, then x phase shift. What's happening?
You go minus pi.
Yes. What's the last piece?
Yeah.
Yay?
That's pretty.
Easy? Pretty easy? B is the only part that's really tricky, right?
You don't take the 3 out, you just, the 2 over 3 out.
So I would definitely write it factored like that. Yeah. Guys, if you try to write it without it factored, you can do that, but you would have to distribute it to that pi over 3, and you'd have 2 pi over 9 as your phase shift. I think it's much simpler to just write the b, and then the parentheses, what the phase shift is, okay? All right, try the next one for me. Again, I didn't tell you so you can do sine with this. What'd you say? I'm sorry. No, it's supposed to be 6. Yep, I know. Weird.
Should you do 0.5 or do you do 1/2?
Either one's fine. Yep. All right, guys, let's think about the b value here. I know 2 pi over b has to equal 6. What does b have to equal? Pi over 3. Pi over 3. Good. All right, go to lunch. Yeah. All right, guys, so same idea here, but instead of me just giving you the information, you have to find it from the graph. Okay? Does this look like a sine or a cosine to you? Cosine. I think it's going to be easier to do as cosine because you've got your max right on the y-axis. Doesn't cosine start up right on the y-axis, whereas sine starts in the middle? Yeah? Okay. Now, technically you could write it as a sine, but we're going to just write it as a cosine to begin with. Okay? So, try to write a cosine equation of this graph. All right? Give me a minute.
I'm giving you this. Yeah. Nope.
How are we doing, guys?
Oh, come on.
Do you still need more? Yeah? More time? More time. I'm gonna watch this off. You know,
I didn't even try.
and look for the midline. Figure out any sort of vertical. What's the highest you go?
It's so much. They were actually.
Yeah.
The things that I have to on.
Like,
Yes, it is.
They
Look at that little one. That's a cosine.
or maybe another figure.
No, it's literally a cosine.
because it starts up top.
I didn't pay. Look at that problem solved.
All right, guys, I see a lot of you leaving the period as 2 pi. Okay, let's look and see if that makes sense. I realize the last thing labeled is 2 pi, but let's look at the graph. If I go from here to there, that's one cycle of the graph, right?
Wait, what? No.
So is the period 2 pi?
No.
No. What is the period then? 3 pi over 2, yes. So from there, you've got to figure out your b value, okay? Yes. Welcome to Free Compound.
That just changed.
All right, let's see how we're doing. Guys, it helps to think about, all right, my maximum is 3, the minimum is -1. That makes my midline at 1, right? So what is the amplitude on this? 2, okay. Cosine. All right, period's 3 pi over 2. So if I solve that, what do you get for b value? 4/3, okay? We don't have any sort of phase shift to worry about though, right? But then your midline is at 1, so we have a +1 at the end. Do you know what I mean when I say phase shift? Okay. You're just thinking of laser tag? Okay, all right. Are you sure? All right, how do we feel about that one? Better? 7? 1 to 10 or 0 to 100? What are we giving a 7 to? Okay, that's not too bad. All right, let's write it again, but I'm going to make you do that. Write another equation of this graph starting with a -2. And instead of a positive 2.
That's tricky.
You can do it. Think about it. No, that's not the thing. The thing, you can do it. Think about what happened. I will look at your time and think.
I have a question. By the negative, does it make it flip over one? Over the x-axis?
So we'll flip over the x-axis first and then shift up. Okay. All right, let's look at it, guys. Yeah. You guys are great. See on the left, like the 3 classes, see how you guys are the top and bottom with the green? So I will always write your stuff on the calendar in green. I don't know why I said 3-4, because it's 3-5 today, right? Yeah. Okay. All right, guys, look up here for a second. So what I'm asking you to do, yeah, it's 3-5 today. But then I was updating the calendar. So. What?
Dates are wrong.
That's November.
This is like in the future.
Yeah. Today's not there. That's starting next week with no school, no school.
No, we have a quiz at 2 in the 3 classes.
You have a fake quiz on November 15th.
That's in like 5 classes.
Oh, I'm sorry, that's okay. No, it's complicated. I have too many classes. This really was the deal. So. All right, so let's look up here. What I'm asking you to do is write an equation that starts with a -2, but will give you this exact graph. So if it starts with -2, that means my first point should be down here, right? The rest of the stuff is going to stay the same. Like we know the period's going to stay the same, the vertical translation is the same. So this is where it would be if I didn't change anything else. That's not where I want that point to be, though. I want it to be over here, right? So what's happening? You could. Because it's cosine, you could go either way and it'd be the same value. Sine is going to give you different values depending on which way you shift. Okay? I'm going to shift to the right.
So you want that to make sense?
Yes.
Oh.
We have to figure out how far I'm shifting to the right or to the left because it's cosine. What is the value? Like, where does that minimum occur? What did you say? Yes.
That's 3/4?
Yes.
Oh yeah, I got you.
This is pi over 2, this is pi, that's halfway in between, right?
Yeah.
Or halfway in between 0 and 3 pi over 2 is 3 pi over 4. Okay, it's very symmetric with where the maximums, minimums, like it's all evenly distributed there.
I thought you just leave it just normal terms because you didn't factor that.
You did factor. If you don't factor, your equation is -2 cosine parentheses 4/3 x minus pi.
Oh,
Because from here is where I get the phase shift once it's factored. And the shift to there.
that's a lot more.
No, this is the shift, 3 pi over 4.
But it's not going to pi. So if you factor it, you minus 2.
Okay, when you go to graph, you factor before you shift. Okay? If you were to label this based on this being 2 pi, this would be pi. But don't do it that way, it's way harder. Okay, the shift comes after it's factored. That's why if you're writing the equation, it's so much easier to write it factored. Okay? All right. Questions? Let's do just find somewhere to write this. We're actually not going to do 9 and 10 on this, so let's do. Very excited. Let me just make up another one for you to write the equation of, because I think you could use a little more practice. Just does not look straight. Well, that's tilted, but oh well. Yes. I haven't labeled anything yet. I'm just making this up for you.
I am so proud.
Works. Let's make this.
Yeah.
I want you to write 4 different equations for this.
What?
Oh, wait, what?
Keisha's just straight up rebelling. No! 4 equations.
4 pots.
What?
That's a 6 pi.
6 pots.
Oh, you would do one?
Yes.
Oh.
So I would do 2 sines and 2 cosines. Okay.
Whoa, that's 6 pi.
That is 6 pi.
Oh, wait, should be.
Figuring out your So the midline
Is 1/2.
right? So that's the midline, right? It's like that.
Oh,
Yeah.
okay.
Not that quick. So how far is it from here? Oh, okay.
Oh, so you should do the stretch.
Did you clap into each other?
You don't have to disagree with it.
Yeah, leave it in factored form. Is the vertical shift going to change on any of these?
Yeah, not only out.
No. Is the B value going to change on any of them? No. Stretch isn't going to change either. It's that C that you're going to have to think about. Woo! Once you get one, the rest are easier. No. Okay, what did you say? Basically A, B, and D. I mean, A changes positive or negative. C is the only thing that's going to change between all four. Think you got it? Okay. It'll come back. I'll give you one. How do we feel about the first one I wrote? So I want like
What was your previous contact?
Dude, no. They're due by.
how far is it from that deadline?
So he's doing it. What was your previous contact?
Guys, questions on the first one I wrote? Are we okay with shifting up a half?
Yes.
Yes? Are we okay with the B value of 1/3?
Does it also apply to the sign?
Yes. I'm going to write 2 sine equations and 1 more cosine equation too, but those pieces are the same in all of them, so are we okay with the half, the third, and 3 halves? Are we sure? If you are not, yes. All of them are? Okay. This is your midline. The half is, so that point right there, do you see how that's a half? Okay, so it's been shifted up a half, that's why I have that. The amplitude then out in front, that is just the distance from the midline to the top or the midline to the bottom. So from a half up to 2, that's 1 1/2, right? Okay, so that's where this 3 halves is coming from. Okay, the period is 6 pi, right? So 2 pi over b equals 6 pi. B has to be 1/3 to make that. So I'm kicking the -1 first because that's the easiest because there's no shift. It's just cosine flipped is all this graph is. So I'm going to write 3 more of them. I'm going to do a positive cosine. I'll do a positive sine.
Say that.
And a negative sine. Guys, do you see how everything's the same except for that C? Okay. For the other cosine, it looks like I'm going to the right 3 pi. You could have done to the left, but I'm going to do -3 pi. Positive sine looks like to the right 3 pi over 2. And then for negative sign, couple of options. You could have gone to the left by 3 pi over 2. Or you could have gone to the right by, what, 9 pi over 2? Take a minute to digest those. How are we doing? Good? For sure? Yes? You what? Oh, 7 out of 10. You're at a 7 out of 10? That's not bad. Alright.
What is? People don't think they were responsible for educating them, so they're others to educate
I know you actually were going on. I realized that today. I was like, well, who has the
I need her more music.
You guys.
I gotta say first.
Yeah.
I have to say,
All right, guys. One more in your notes. Let's go back. Try number 11 for me. One more. Do you guys see it says select all that apply? I know, those are tricky.
who is he?
Do not graph every single one of these, okay? Really don't graph any of them. Just think about what's happening. Okay. Okay, guys, because we're running out of time, let's talk about these. So if your range is -2 to 10, distance, how far is it from -2 to +10? 12. Half of that is then your amplitude. So what's half of 12? 6. So I see 3 of them with an amplitude of 6, right? So I can get rid of this guy. Now let's think about it. If we are going -2 to 10, amplitude of 6, where does that put your midline? 4. Do all of those have a midline of 4?
Yes.
Yeah, it's all 3 of them. Doesn't matter if it's negative or positive in front, whether it's flipped or not, that range would still be the same. Okay? You didn't understand that one? Homework is in your packet, guys, okay? You have a long time to do this. I don't see you till next Wednesday. Yeah. I don't see you till next Wednesday. You don't have school Monday or Tuesday.